So we're going to pull up, to figure out the derivatives of exponential logarithmic functions, we're going to pull up our graph here. I'm going to grab this point, and again, there's my tangent line. The blue dot that is highlighted there is the slope at that point. So it sort of looks like right here. Does it look like that slope is 1? Kind of looks like the slope is 1. And so that blue dot is actually right where I'm going to grab it. Now I'm going to drag my tangent along the line, and the blue that's being made is the equation of the tangent. What do you notice? What's the relationship between the blue graph that just got drawn and our original graph? They're the same. Thanks. Okay. They're exactly the same. Fascinating. The number e that you learned about before is the only value where the derivative of an exponential function is exactly the same as the original function. So if we go to our notes now and we click on this, or move it to the side, the derivative is the same. It doesn't change. Terribly fascinating. So what's the derivative of 2e to the x? 2e to the x. Okay? I don't know if sometimes when you're stuck on a question on a test, do you ever just like write out the question? So this would be one of those times, I'm stuck, I don't know what to do, I'll just write it out. I'll skip to the next one. And you get full marks afterwards. And you're like, oh. Now, the natural log of x, which has a base of e, doesn't turn out exactly that nice. But we're going to see if you can figure out if you can recognize from your graphing skills from last year what that blue graph is. Now, when you learned that blue graph originally, it also had stuff when the domain is less than 0. Of course, the natural log of x's domain is just greater than 0, so you only have this part. But if I were to draw for you, so the derivative that was drawn was this part. If I drew the other part of the graph, do you recognize it now? What is the equation of that graph? One over x. Now this one is going to cause some craziness to happen a little bit, because 1 over x, you could also write it as x to the negative 1. Now remember before when we were doing the power law, I had some questions that said work backwards. So if that's your derivative, what was your function originally? Well, what did you do? You added 1 to the exponent, right, and said x cubed. Oh, and I don't have to put anything in front because that 3 would have come out in front. This one's going to cause some problems because this is like a power law. And I say, well, what happens if you started with this? What would be working backwards? And you'd be tempted to say, oh, I just have to add 1 to the exponent. Well, what happens when you add 1 to the exponent? You get x to the 0. And then you would need a number in front. So when you multiply 0 times this number in front, you get 1. And now you start to go, my brain is not working right. 0 times something is 1. and we have a problem. Okay? But crazy that this x to the negative 1 actually does have a derivative or original function, and that's the natural log of x. Whew. Fun. Okay. So now we can do some simple derivative questions. And sometimes because they're simple, they're going to cause you problems. Because for this one, the derivative of e to the x is e to the x. So nothing changes. And that's hard for people doing math because you feel like you want to do some progress while you're doing the questions. And you feel like you haven't done anything other than rewrite the question. And we already learned that adding and subtracting things, you can think of each thing separately. So can we do our derivative of x cubed? Yes. 3x squared. Can we do our derivative of 3 natural log of x? Okay? Now, eventually, you'll probably just write the answer to this, but what's happening, the 3 out in front doesn't affect anything. It's going to be 3 times by, what is the derivative of natural log? 1 over x. Eventually, you might just go right to 3 over x as well. Either way would be fine. Okay? At the beginning, I'd recommend writing it like this so you can really see what's happening. But then 3 is just a fraction, 3 over 1, so you could multiply it out to get 3 over x. This question will be more difficult a week from now than it is right now. The reason for that, don't you hate that? I'm gonna teach you something to make this question harder. Thanks, Mr. JR. Sometimes more knowledge makes things more difficult because you have more options to think about. Right now, you don't have many options because we haven't learned product rule, quotient rule, chain rule. We haven't learned those things yet, so your brain doesn't immediately jump to try to figure out one of those things. Now, all we have right now is we know the derivative of e to the x. We know the derivative of the natural log. We know the derivative of simple things. We also know all of our log laws from before. How can we apply our log laws to this situation? What do you know about natural log and e? They're inverses of each other, right? The natural log of e is equal to 1. Okay? What do we know about our log laws? Whenever you have an exponent inside, what can happen with that exponent? It could come out in front. So we could bring that 5x out in front and then get 5x natural log of e. And then what Sam said, well, the natural log of e is 1, so this just becomes 5x. And so our derivative of 5x is just 5. Try example 2 on your own, so we're done exponential and log functions. Pick up a pretest on your way out.